Hey Geometry, we are ready to do some triangles. You guys gonna like this. Today we're gonna be classifying triangles. So angles in a triangle all have certain degrees, but one thing you have to know is that all angles in a triangle add up to 180 degrees. You need to know that, okay? So you need to know that when you take the measures of each angle in a triangle, it's gonna add up to 180 degrees. So we're going to talk about the angles in the triangle first. The first type of triangle we're going to talk about is called an acute triangle. You guys have already learned that acute means that all angles, an acute angle means the angle is less than 90 degrees. So if I were to draw three angles, this one would be less than 90 degrees. If I took a protractor and I put it on there, that's probably about 35 degrees or so. This would be equal to 90 degrees, and then this would be greater than 90 degrees. That would be greater than 90 degrees. So acute is all the ones that are less than 90 degrees. So when you look at the measures inside your triangle, all you need to do is figure out, is each number less than 90 degrees? Well, yes, they all are less than 90 degrees. It's acute, okay? And you can think about, oh, it's a little cute triangle. It's cute because it's small. So all the angles are small, less than 90 degrees. There's a triangle called equiangular. Equiangular means that all angles are equal. The only way to figure out how much the angles are going to be if they're all equal is take the total amount of degrees in a triangle and divide it by 3, because there's always 3 angles in a triangle. When you divide 3 into 180, you get 60. If you notice in an equiangular triangle, all angles are 60 degrees. Okay, then we've got something called an obtuse triangle. Obtuse means that there's one angle bigger than 90 degrees, so we're going to have a really big angle. In this triangle, you've got this really big angle that's 130 degrees. When you add them all up again, they'll equal 180. But the obtuse means bigger than 90 degrees. And finally, the last kind of triangle is called a right triangle. A right triangle will have a 90-degree angle in it. It will have 2 perpendicular lines, okay? So that's right triangle, one angle, 90 degrees. So let's look at some examples. I have 4 examples. Okay, let's look at this one. This angle is 60, 30, 90. Is that acute? Is it equiangular? Is it obtuse? Or is it right? Well, hopefully you noticed that there was a 90-degree angle there. That is a right triangle. Okay, let's look at this one. 40, 70, 70. Is it acute, obtuse, right, or equiangular? Well, all the angles aren't equal. There's no 90-degree angle. There's no big angle greater than 90 degrees. They're all smaller than 90 degrees. This is an acute triangle. Now we have 20, 140, and 20. Is it equiangular? Is it acute? Is it right? Is it obtuse? We notice that this is bigger than 90 degrees. That is an obtuse triangle. And finally, 60, 60, 60. They're all equal, so that is equiangular. Okay, there's other ways to classify triangles. You can classification, I should say, of triangles by sides. So the first type is that all 3 sides are equal. In an all 3 side equal triangle, all 3 sides are going to be the same length. You'll see these little things. Each side has the same length, which is 6 in this case. Now you're going to find out that all equilateral triangles are also equiangular. I know that if it's equilateral, all the angles are going to be equal as well. This one is called an isosceles triangle. You need to know how to spell isosceles. It's I-S-O-S-C-E-L-E-S. This means that 2 of the sides are equal. Okay, so if you look here, you have 2 sides that are the same length. So they are both 10. This is isosceles. The last one is called a scalene. No sides are equal. So if you can see, this is 5, this is 10, and this is 12. That's scalene. Equilateral, isosceles, and scalene. Okay, one of the cool things that you'll learn about isosceles is that base angles in an isosceles triangle are also equal. So these 2 angles across from the same length in the triangle are going to also be equal. So let's go over here. We're going to try to figure out some of the either angles or what kind of triangles they are. So we'll look at our first example. This says these two are 45. We don't know what that one is. That's 59, that's 31. That tells us it's 90 degrees. So what we want to do is find out what kind of triangles each one of these triangles is. Well, the first thing I'm going to tell you is that you know this is a straight line, and you know that this is 90 degrees. When you have a 90-degree angle here, the other angle here is going to be a 90-degree angle. So this triangle right here is right because of the 90-degree angle, as well as this triangle right here is right. So we know that the two little triangles are right. Let's see what it asks for. Triangle PQR. You need to figure out PQR. That's the big triangle. So let's see what we have. We have a 45-degree angle in P, a 31-degree angle in Q, and then, in R. Q is actually these two added together, 45 and 59. So I get 104. Guess what? A 104 angle is obtuse. So this big PQR is an obtuse triangle. Okay, how about PQS? PQS, well, we already determined that it's right. And how about QSR? QSR, 90 degree, it is also right. You can't have it be right and acute or right and obtuse. It's going to be one or the other. The only time you'll see one that can be two according to their angles is equiangular and acute, because equiangular is 60 degrees in all and acute is smaller than 90. So you will see that there. Okay, here's my next question. If point M is the midpoint of JL, classify triangle JKM as equilateral, isosceles, or scaling. The first thing you need to understand is what a midpoint is. The middle of a segment. So if you're given a segment is 10 inches, okay? Let's say you're given this segment is 10 inches, and they tell you that the midpoint is M. What that tells you is that you have to divide this number into 2, and you will get that that's 5 and that's 5. Okay, so a midpoint means it's right in the middle, middle. Okay, so we want to find out what JKM is. What kind of triangle is JKM? Is it equilateral, isosceles, or scalene? I think I forgot to put the K here. Okay, well, I know that KML has 2 equal sides, so I know that KML is isosceles. So KML is isosceles. I'm just going to abbreviate it. I also know that in the question it told me M is the midpoint. Well, if this is the middle of the segment, then I can figure out how much each one of these is. This whole thing in the picture tells me it's 1.5. So how do I figure out how much each half is? What I have to do is divide 1.5 by 2. 2 goes into 1, 0. 2 goes into 15. Now notice I put the point up there. 2 goes into 15, 7. And then I have to add a 0 and bring that down. And 2 goes into 10, 5. That means that when I divide this in half, I get 0.75 and 0.75. Well, look at what you notice. 0.75, 0.75. That means these two those two are equal. Okay? Now, if these two are equal, and this one's already equal, then it looks to me, since this is equal to this, which it told us in our picture, what does this look like? We want to know if is it equilateral, isosceles, or scalene. Well, because of all these slash marks, and we know they're all the same size, angle JKM is equilateral. So the answer was equilateral. All the sides are equal for this. Okay? So let's look at our last example. Find the measures of the sides of isosceles triangle ABC. This is key that it tells you what kind of triangle it is. So you need to know, okay, how am I going to find the measures of the sides? Well, there's x's in each one of these things, so I'm going to have to figure out what x is And then I'm going to have to go back and plug x in to figure out how much the measure of each side is. Okay, this is key. When they tell you two sides are equal, you need to set them together to be equal. So you're going to be solving some algebra here. Okay, so I get 4x plus 1 equals 5x minus 0.5. Okay, so let's do the algebra. I'm going to subtract 4x from both sides. Draw a line down the middle here. That cancels out. I get 1 equals x minus 0.5. How do I get 0.5 to the other side? I have to say what's happening to x. It's being subtracted by 0.5, so I'm going to add 0.5 to it. Okay, and then I get x equals, and this just means 1.0, because 1.0, when there's no point, you know the point's right there, plus 0.5. The answer is x equals 1.5, but I'm not done because I have to go back and plug that in for all three to see how much each side is worth. And I know these two sides are equal. So let's do side AC first. So AC equals 4x plus 1. But if I know 4 times x is 4 times 1.5 plus 1. So I'm going to do 1.5 times 4. And I get 24, 5, 6. So AC equals 6 plus 1, which equals 7. So I know this side is 7. Well, if I know that side's 7, these two are equal, it's isosceles, I know that CB is also 7. So that's easy. CB is 7. So now all I have to do is figure out 9x minus 1, and then I'm done. AB equals 9 times x, which is 1.5, minus 1. So let's do 1.5 times 9. 45, carry the 4, 9, 10, 11, 12, 13. 13.5 minus 1, and you can put the 0.0 there, is 12.5. So my final answer is that AB equals 12.5. I think you're going to like this, guys. Have a good day. Bye. Thanks, Jared.